My name's Mike Pitaro. I'm a principal architect at Dell working on big data solutions. I see a few familiar faces through the lights. Some of you may know me as an OpenStack contributor, and I kind of dropped off the scenes because for about the past 9 months I've been working on big data solutions. So secretly, this little project we're talking about is my way of getting back to OpenStack via Hadoop. You can find me online. I'm pretty easy to find. Usually Twitter or Freenode is MonkeyP or PMonkeyP, which is supposed to be the personal Twitter. That way nobody thinks I'm tweeting on behalf of some company. And what we're going to talk about today is Hadoop for OpenStack log analysis. So the way I put together this presentation, I've never done it before, so timing's going to be a little tricky. But the way I put it together, I thought I would talk a little bit about the project we've been working on at Dell, and go through a high-level overview, then switch over to the demo if I can get everything to work with the projector here, and then we'll go back and kind of drill into more of an interactive discussion in QA, and I'll tell you some of the things we've been looking at. Sound good? Sure. So before we go there, how many people have heard of Hadoop? Oh, good. How many people actually know what it is? Oh, we're doing pretty good there. This is the DevOps track. I need to start with that. So let's talk about the problem I'm trying to solve. So the issue we're dealing with is very simply running OpenStack at scale. It is very difficult, challenging to run OpenStack. There are a lot of moving pieces. I love Ken Pepple's diagram because it puts everything on one page and it looks simpler, but it's still kind of messy. The issue you have is introduction. There's a lot of things happening. And if you're an operator and you're actually trying to run OpenStack, figuring out what went wrong is a problem. So this is the focus I have on this project. What we're searching for is really the holy grail of OpenStack operations. The big challenge for an operator is really to say, what would happen if we could follow a request through the entire system? So starting with a request into Nova API, follow it through the system, across compute, across storage, across networking, independent of the physical nodes or where things are running, independent of if I move services around, actually catch timestamps on that activity, and potentially correlate that with things that were happening outside of OpenStack. So to me, this is the holy grail of log analysis. I like solving hard problems. The good news is, some of us were trying to do this before invisible horses were cool. So we've been doing this for a long time. We have some ideas about how to solve these problems. This is actually kind of easy. We learned the story. The good underpants gnomes taught us how to do this. It's really very, very easy. You collect the logs, you analyze them, and you get to sleep at night. The truth is, when you really get into this problem, though, it's not quite that easy. Having looked at this, talked to a lot of Dell customers, talked to other people in our team doing QA work, the reality is this becomes a big data problem. People have various definitions of big data across the board in terms of what they think it is. I like this definition. It's a variation of one that comes from O'Reilly. I think it was Steve Margolis's definition. I like to say just big data is when the data itself is part of the problem. The original definition is when the size of the data is part of the problem. And that means you're dealing either with high volume data coming along very, very quickly, or you're dealing with velocity, or you're dealing with just variety, the different types, the structure of the data. And generally when you get into log analysis, the data is part of the problem. So I think it fits into a big data problem. The problem is, now I talked about big data. So that suddenly puts us into the hype curve. Big data is on that very, very hot hype curve, and it's probably going to outdo the .com, I think. In terms of the peak of the hype curve and the trough of distribution and all that. But because I mentioned big data, I think it's important to say, I don't want to get into all this fancy stuff. What we're trying to focus on is a very narrow focus. So rather than solving all the world's log analysis problems, the focus right now with the work we're doing is number one, operators. So I'm thinking in terms of the DevOps teams, the operators running OpenStack. How can we assist them in running OpenStack? I'm specifically not thinking about tenants, so I'm not trying to do or work on something like a CloudWatch. We're just thinking about running OpenStack for consumers. The second focus is very much looking at the data. So grab as much detail as we can from the log system, extract and index the really important fields, and get it into Hadoop so that we can do future analysis. And the third thing we're focused on is the patterns. So since it's the DevOps team, we know there's no perfect solution. We're going to need help figuring this out. So part of our focus is, what works, what's repeatable across multiple installs that we can factor out and turn into a really useful thing for the community. And then finally, how do we get some help? How do we collaborate? What are other people doing? What sort of challenges are you seeing out there? And the reason for the logcat here is just the distraction, right? Whenever you talk about big data, people tend to go off on tangents and all the wonderful things we can do. It's cool, but we're very much focused on operators, data, patterns, how we actually deploy this stuff out. I thought it might be worth talking a little bit about Hadoop. I realize not everybody here is a Hadoop expert. This is the OpenStack Summit. But in terms of Hadoop, I think the first thing to talk about is, why use Hadoop? And I think there are a couple of reasons. For one, it's open source. Number two, it has a huge ecosystem. And number three, it's a really good data processing and storage platform. So there are a lot of good things about Hadoop that fit in towards this problem. In terms of the simplified block diagram, at the lowest level of Hadoop, you have something called HDFS, the distributed file system. This is not a POSIX file system, so you're not going to take this thing and map it to block storage in OpenStack anytime soon. Maybe someday somebody will do that. But it's very much a distributed file system optimized to support parallel processing in the next layer of Hadoop, which is the MapReduce framework. For example, in HDFS, block sizes are typically 64 megs, 128, 256 megs are just not at all unusual in a Hadoop implementation compared to a traditional disk. Above HDFS, the next level up is something called MapReduce, which is named after the original Google paper that described this, and it's a parallel processing framework. From a programmer point of view, MapReduce is interesting. I'm grossly simplifying here, but you write a loop, you submit it into Hadoop. Hadoop will take this loop that's processing a file and reading through it. It will parallelize it across a cluster, run it in parallel, and let you merge back the results as if that loop ran on one CPU. It's a gross simplification, but that's really what Hadoop does under the hood. And it's interesting because it makes parallel processing accessible to programmers, particularly enterprise programmers, that have never done parallel processing, message passing, async I/O, all of the things that we do in the guts of OpenStack or the guts of other systems. It just makes it easy. So on top of those two layers, HDFS and MapReduce, there are a large number of tools above there, kind of part of the ecosystem. So you have things like Pig, which is a batch processing language. You also have Hive, which is what I would call a SQL-ish query. It's kind of the data warehousing component of Hadoop. I say SQL-ish because it looks like SQL, but it's not really SQL because Hadoop isn't a relational database. So it's not a perfect match, but it's getting there. And then you have other tools, Oozie for workflow management, Hue for the web UI, you have Mahout for machine learning. These are all interesting tools, and they're part of, I believe, every Hadoop distribution out there. So these are like the standard command line basic utilities to use with Hadoop. There are also a set of APIs. So Hadoop is, like OpenStack, it's APIs everywhere. And a lot of those APIs are used by both those tools in green and other utilities. I think the main ones to mention are there's JDBC interface, so you can get to Hadoop as a database, or at least get to things like Hive as if it was a database. And there are tools called Scoop and Flume. Scoop is a database connectivity tool that lets you do database imports, exports between Hadoop and other systems. Flume is a tool that's used to stream data into Hadoop if you're doing real-time or semi-real-time collection, and that's something we'd be interested in the log analysis side. I deliberately skipped HBase. HBase is the Hadoop database. It puts a table-style interface on top of the core HDFS system. So this lets us, by putting that interface on top of HDFS, you can let people treat Hadoop a little bit like a database. It's actually pretty much like a database. It has indexing and it has queries, so again, a powerful tool. But this is the big picture on Hadoop. Again, I'm grossly simplifying. I just wanted everybody to be on the same page. When you really work with Hadoop, there's a huge ecosystem. So there are vendors doing both distributions and tools. At Dell and the solution we work with, we regularly work with Pentano and Datamir and Kitenga as kind of high-level analysis tools. None of those are in scope for kind of the work I'm doing with log analysis. It's like, look, let's get the data into Hadoop and figure out what we find. Did I lose anybody? It's time, quick check. Anybody putting up their hand saying I'm lost? Oh, good. So if you think about the log problem, the real question is, what are the big pieces of this log analysis in OpenStack, or what are we trying to do here? So one thing is, we need to deal with log collection. So someplace along the line, if we go back to that initial picture of the complexity, we need to pick the logs up, we need to get them into Hadoop. What I think, the second part I think is important is what I would call intelligent log parsing and indexing and searching. So whatever we build and release here should know something about OpenStack. It's not just looking at blind text files and analyzing them. I think it needs to have some intelligence. It may not be super intelligent. A third part is the storage organization. So the dirty little secret in Hadoop is it's actually a bunch of files. Don't let anybody fool you. There's files scattered everywhere. It helps to put some sort of structure on top of that in terms of the data formats and the directory organization so you can actually make sense of it. There are multiple ways to do it. You just pick one and say, this is the standard we're using for this implementation. A fourth one, this one's going to be tricky. So Hadoop's a fairly complex system. It probably rates up there with OpenStack in terms of complexity. I think it's been around a little longer, so there are pretty well-established patterns for running Hadoop. But I don't want to bring something into the DevOps infrastructure that is as complex as OpenStack, because that doesn't solve our problem. So the idea here is to keep this straightforward, get the data from OpenStack to Hadoop, perhaps let the Hadoop people run Hadoop, let the OpenStack guys run OpenStack, and just keep the connections between the two as straightforward as possible. Otherwise, we won't succeed in the log analysis problem. And then the last thing is, as we go through these big pieces, once we're getting the logs there, once they're in Hadoop, we start opening the door up to future analysis. By getting the stuff into a good format, people can actually pick it up and do something useful with it. And there are data scientists who will look at data that you give them just white box fashion, they've never seen it before, and they'll analyze it, tell you what they find. Sometimes they find interesting stuff. This is kind of the big picture on what the whole thing's going to look like. Some of this is in place, so I'll get into the details of what we've actually accomplished so far. But the broad idea is the core of the system is going to be HDFS, so the Hadoop Distributed File System. We're going to set up HDFS and let the operators go hit this thing with Pig and Hive, the two most popular tools to work with Hadoop. And they'll hit HDFS, access the data, get something out of it. We could put layers and layers of ecosystem tools here in terms of what they use to get it into a dashboard or something, but those are the basic tools. Within HDFS, the goal right now is to store the data in a format called Avro. Avro is a file format that's a cross-platform serialization format. It's nice because it has pretty good cross-language support, and it has pretty good cross-platform support. Language becomes important here. I kind of glossed over the detail, but most of Hadoop is written in Java. So interlanguage operability and cross-platform stuff becomes very important when we work here and bring OpenStack into the mix. In terms of the collection model, there are some set of OpenStack nodes. And by nodes, I mean physical machines running OpenStack services. So I don't care right now which services are running on them, but whether it's Nova Network or Nova API or Quantum or Swift or Ceph, doesn't matter where they fit into the system. They're going to be nodes, and right now I've used the red boxes to indicate that this vague thing that somewhere in OpenStack there's going to be some Python logging code and there is some syslog logging code. The goal here is to hook off that, use Flume as a utility to pick up syslogs and Python logs, stream them over to the Hadoop cluster, probably using several Flume agents along the line to do the log collection and stream the stuff into Hadoop. Once we get past that point, I think, this I haven't really dug into yet, but the secondary plan is to pick up some stuff through Scoop and Flume and collect some of the data from the infrastructure. So Nagios, Ganglia, whatever other systems we have there, potentially SNMP from switches. It'd be nice to get that in there, but the initial focus is the log analysis. At the same time, while the data goes into HDFS, the trouble with HDFS and Hadoop is it tends to be a fairly batch-oriented system. Really good for processing big data sets. It's terrible for doing fast queries and saying, what's this thing say right now? So we'll take the data, once it comes into HDFS, or maybe in parallel with going into HDFS, the plan is to run MapReduce jobs, is the way I'm doing it now. We run MapReduce jobs and we build Lucene indexes that we can feed into a Solr cloud. So by running Solr in parallel with the Hadoop cluster, I can use Solr. Does everybody know what Solr is? I probably should have explained. Solr is the search engine that powers an awful lot of these public-facing websites, so it's a really good, fast text search engine. So you can put the data into Solr, and you can do quick searches on the log data to find stuff that you're interested in. So think of it as like grep in parallel on steroids. And then within Solr, we can then store hooks back to the actual data in HDFS. So I get the fast query on some of the data, but I have hooks back to the deeper data if I actually want to run an analysis and go through it. So that's kind of the big picture of the various pieces that are here. In terms of the current status, where we are today, so it's currently a batch-only system. We haven't quite worked out the details of the Flume collection. The good news is that's a well-established tool, so it wasn't a big problem to solve. I'm focusing on the hard problems. But in batch mode, I'm able to take OpenStack logs, run them through some utilities, and get them into Hadoop. We're converting them to Avro format. So normally, most of our logging in OpenStack is text. That data is being converted to Avro, which is this more structured, schema-oriented format, and it's going into Hadoop that way. There's a first cut of the schema. I think I have it here on a later slide, so it's not a polished schema, but it's an initial cut. It's fairly simple. And that data is going into Hadoop. From Hadoop, we're currently creating Solr indexes, so we can do a quick search in Solr to look at the data and kind of get a feel for what's there. And beginning to start looking at the data itself, so using Pig, using Solr, and kind of looking at the data and saying, how do we really want to structure this going forward? So that's the current development status. It's not releasable yet. It's very hackish, I will admit that. It's really a prototype, but I'm bringing it here to see what people think and try to figure out where we should go with it from the next step, for the next steps. I wanted to look at a demo, but I realized the trouble with these presentations is you don't know which order to cover things. I thought before we take a look at some data, it probably made sense to think a little bit about the schema. So at the top here, I just took an OpenStack log message. Actually, it's fairly recent. Dropped it at the top of the screen, and the little red boxes indicate the fields that are being parsed out. This body of text on the right is the Avro schema that I'm mapping it into. And the basic idea is we parsed out the host name, which actually isn't a log file, but I think it makes sense to track host name when you collect a log. We got the date, the time, the message level, the module. We got the request IDs. Some messages will contain those request IDs, so they're flagged in the schema as string or null, which means they're optional fields.
There's no logging standard now in OpenStack? Are there any logging standards?
The question is, are there any logging standards? So I think with Oslo, we've kind of moved logging. Somebody correct me if I'm wrong, but I think logging is now a common module.
Yes.
So we have a fairly standard logging method for all the OpenStack services. Swift happens to go through syslog right now, but everything else goes through the Python logging. So I think where we're going to end up is at some point, we're going to take the Python logging module and figure out how to get it to just log the data right out in Avro format if it's not easily available already. There may actually be a plugin that does that. That seems obvious. I don't know about deeper structure on the logging messages, but I thought this is a good start. You know, we're just parsing out the key fields, getting them into a standard schema. I thought a reasonable demo would be to talk about where we are today. And then there's a whole bunch of other stuff we can talk about, but I'm between you and lunch. We started the quarter past, right? So I think we've got a lot of time to do a demo. So I want to shift over here and do a quick demo and show you where we are today in terms of being able to look at solar and also take a look at PIG and some batch analysis. To do that, we need to get out of PowerPoint. I need to connect to this tiny little Hadoop server down here on the table that you guys can't see, but if everything went well here, I'll be able to log in over there. Bear with me while I do some hacking here. It's always interesting looking at history compared to I don't know if I got an IP on my local network, so. I think it VPN me into the Dell corporate network and it's doing something funny, so. Ooh, we're looking good. I see an IP address. The demo may not cooperate, but I'm going to give it one more shot here for a moment. While I'm waiting for that machine to reboot, let me jump back over to my PowerPoint stuff and see if I can start walking through the next couple of slides, because I think it's not going to cooperate. It was working a little while. You can never win. Demo not going to cooperate right now. Slideshow. So maybe the demo will work, but what I'm going to do is go through the remaining slides, and then if anybody wants to hang around while I try and show it at the end, I'll do it then. So I was kind of touching on where we were in the current setup here for the project. It's very much, it's prototypish. You know, I'm working with a couple of people within Dell. I'm working with a handful of Dell customers that are interested, and some people in the OpenStack community that are very interested in this. So some of the thoughts we had other than the schema, when you think about data collection, the general idea here is to go after mainly the OpenStack logs. So go after the core logs first, syslog, maybe Nagios, Ganglia, other infrastructure data. I think that's relevant in the context here. And general infrastructure data, network switches. maybe pick up SNMP data, or maybe proxy it through a Nagios and let them deal with the ugliness and we just pick it up from the database. I've deliberately not included Sealometer here, although I've been in almost every Sealometer session here. So there is a backend for Sealometer that currently puts data into HBase, which Shenji here developed. And that was some guys at Dell that are already doing that. I think Sealometer data is very interesting for analysis, but to me it's not quite the same as just the operational monitoring aspect, but I think eventually it'll come in here. For input formats, we're mostly dealing with semi-structured text. I want to track the subsystem. I think we need to track the host name, the timestamp, the severity, and the error level. When I say host name, I don't know if we should track host name or IP address. It's kind of up in the air, but I think we do need to tie each log back to the original machine. For output formats, this is a little tricky. Protocol buffers are an option, but they're not very portable across languages. They're kind of a C, C++ thing that Google uses. They're interesting, but I don't think they're very portable at this point. Also, they haven't had a lot of traction outside of Google. The two formats that have had traction are Avro and Thrift. I'm not really an expert on the subtle differences between those. They both solve the same problem, which is a serialization format that's pretty much cross-platform, cross-language. I chose Avro primarily because it has some nice schema evolution features where you can put the schema in the file. The beauty of an Avro file is when you apply a schema, it's embedded in the file. So you don't have like XML where you have these external schemas and you have to validate against DTDs. With Avro, the schema is just loaded in the file header, and it's also a very compact format. But Avro Thrift, I think somebody will call me out on this, but they're more or less equivalent. The reason I'm using Avro is the Hadoop community seems to be very, very quickly converging on Avro is their most universal file format at the lowest level. So I'm open to suggestions here, but at least that's what everybody tells me. For log collection thoughts, the reason we haven't really dealt with the Flume kind of streaming stuff right now is it's a well-established problem. There are some nice patterns and best practices in the community, so it's not a research project. We'll be able to pick a path, follow it, it's likely to work. The tools that are used a lot, Kafka, Scribe, Flume, and FlumeMG. I've started focusing on Flume because, again, that seems to be where the Hadoop community is going, towards FlumeMG. If somebody made a strong case and said we absolutely should use Kafka, which a couple guys at the Hacker Dojo in San Jose twisted my arm and said, you really need to use Kafka. It's a possibility, but right now FlumeMG seems to be doing it. It's pretty popular with people. The key requirements on the log collection side isn't so much the tool. It's that it supports a distributed infrastructure, that it can do reliable log collection. So depending on the tool, all of these tools have a mechanism where they can kind of buffer data in memory or buffer it to disk and make sure that they reliably forward it ahead. Because you don't want to be dropping log messages during a temporary outage, but you don't want to fill up the collection nodes when they get busy. So a store and forward, some concept of aggregation. This is going to be tricky, the actual topology, how we handle the distributed nodes, how we aggregate the logs from, say, a cell or a data center, and how you break that up. I don't think that's going to be coded in the solution. I think it's going to be something you can choose at deployment time. How do you want to aggregate the logs and stream them back to the master Hadoop cluster? Those are some of the things that are up in the air. So when I call these thoughts, these are like, don't know the final answer yet. Actually thought about these, but haven't solved the problem. That's on the log collection side. On the organization side, the big things are, as I mentioned, Hadoop being a bunch of files in the file system. It's things like, how do we do the file organization within Hadoop? How do we name the files? How do we organize the directories? If you were in one of the earlier talks, they were talking about Swift as a backend for HDFS or Hadoop. And they're doing things where the files have slashes in the names and they're building a directory hierarchy in Swift. It may not be the best idea, but within HDFS, you have to have some sort of structure or you lose track of the files. You just kind of formalize that. Maybe it's a pattern. The data lifecycle is probably more important. As the data comes into Hadoop, you're streaming it in. You're probably going to want to stage it someplace, either a local disk before it gets into Hadoop or in Hadoop itself. Then we'll have MapReduce jobs picking it up and doing something with it. So I talk about hot and cold data. What do you do with the data from the last 15 minutes? Do you just try and get it into Solr quick, have a very, very fast index for analysis, and then kind of move it into MapReduce? Or do you do it the other way around? Things like how we tier it. Big debate. I got really good feedback from this, from the team at Paypal, which I should say thank you to. I can't see you guys if you're here because of the lights, but you are here. They suffered through an early version of this presentation and kind of been collaborating on what's going on. But the idea of tiered indexes is the data comes into the system and you're building the indexes in Solr, you can't index everything. It's going to be too much data. So what do you index? Do you index it in 15-minute intervals? Do you do 15, half an hour, and 45 windows? There's some discussion around that. I don't know the right answer yet. I don't think it's a fundamental design decision. And again, that may turn out to be something that's a parameter depending on the implementation. But tiering that data is important. Within Hadoop, what do you compress, what do you not compress? Your fresh data, you probably want to put it in there uncompressed, initially get the indexes built. But at some point, you want to take advantage of Hadoop compression so you can keep more log data in the cluster. You may want to throw it away after a day, but I think most people are going to keep more data. And then, at the tail end, once you have compressed the data or not, are you going to keep 15 years of OpenStack logs? Maybe you want to archive them to tape. Maybe you just want to have them automatically fall off the end. I know some Dell customers that actually take their log data, not just from OpenStack, but other places, and they archive it in Swift. They got compliance restrictions, so they take the original logs, they copy them to Swift, and that's like their master copy, and then they load them into other systems for analysis. So these are things that are, I have some ideas. I need to talk to other people and see, what do you think of this? It's probably a little design session to sketch it out. Which really takes me full circle to, where do we go from here? In terms of what we should do next, this is very much a prototype. I'll show it to somebody if you want to hang around. It is on this box. But should we document what we have now? Anybody else know of a related effort? So I'm plugged into the Ceilometer project. There is a blueprint for the universal request ID, so we can follow a request through the whole OpenStack system. That blueprint is in progress right now. A lot of these things are not hard decisions. I think they're going to take some people that have experience with this. We sit around on a table or an IRC channel and we say, let's do this, and we kind of agree we'll do that until somebody proves it a bad idea. That's kind of how I do things. We need some collaboration on the schema design. What's the right structure of the schema? We'll probably look at other implementations of log analysis to see what they do as well. Do we need changes upstream? I'm pretty sure we're going to have to tweak the Python logging. I'm not even sure if that's going to be an OpenStack change as much as a Python change. But at a minimum, it'd be nice to have OpenStack logging go straight to the stream instead of writing to a disk. I don't know if that's going to be a plugin to go straight to Flume or if it's going to be an Avro translator with some sort of Flume hook. That's probably going to happen. I don't know if there are other upstream changes. We'll know as we get deeper. And then I think the last thing is something that's come up multiple times is it would be nice if while we're doing this, we could get substantial sets of Hadoop log data kind of put together in an Avro format and give them to some Hadoopians and let them look at it and say, what do you find? So that they can start analyzing it soon. There are a lot of people that have clusters that they're looking for work to do on them. I think we can give them some work to do. So those are the big level topics. I think at this stage, as we come up to, we're running a little late for lunch, but as we come up to this, and at the summit all week, so if I go back to the original slide, you'll find me around here. I don't know if there's interest in having kind of an informal design session around this on conference style. Anybody interested? Or I'll also be, okay, so we do have interest, good. And I don't know how we'll coordinate that. We'll figure that out as we're breaking for lunch. But we should do that and kind of do a little more brainstorming. It's our intent to release this as a pattern with as much code as we can. It becomes something we can apply to multiple OpenStack distros and installations, but it's evolving right now. Okay, well, thank you for coming.